going to get started here in just a minute. We'll get our live feed rolling on the Facebook here shortly. And I see it just turned 6 o'clock. Matt, are we ready to go? And there we go. We're live. Okay, wonderful. Hey, thank you all for coming out this evening. It's so wonderful to see a little bit of rain out there. This sure beats the heck out of a forest fire, right? My name's Mike Ray. I'm the Media Relations Manager here at Sanford Underground Research Facility. I want to welcome you to the April edition of our Deep Talks event here at SURF. It's great to see so many folks out. We've got a wonderful evening ahead over the next hour. We're going to be talking about all things surf. Normally during April we do our surf update, and this is always a fun evening to hear the latest and greatest things going on at surf. But first, we need to thank our sponsors, the folks who provide the wonderful beverages and the wonderful food that we have every month. Deep Talks is made possible by Crow Peak Brewing Company. We're going to hear more from them with a wonderful beer. Yes, absolutely. Edward Jones Financial Advisor Chris Mitchell is another one. RCS Construction, we thank them. And Charles and Jolene Lichtenwalner. Let's give a round of applause for all of those wonderful folks. We're going to start with talking just real briefly about the most important part of the night, and that is the beer. Larry Bakke with Crow Peak is going to say just a few words. Again, thank him for his sponsorship. Here you go, Larry.
Thank you. So I'm Larry Bakke with Crow Peak Brewing in Spearfish. Crow Peak Brewery is one of the oldest breweries in South Dakota. And it's been kind of fun for me because I've been in the mining world for 40 years. And I recently took the job at Crow Peak as manager. And one of the things I've really learned about brewing is there's a science to it, right? And so the camaraderie with scientists and our own brewers who are just amaze me all the time, learning the process. It's really an important part for us to be here, and we're very honored to be here because we want to foster the education and science that SURF is in the process of doing as well. So we really thank you for the opportunity to be here. Come and see us. We're just off of exit 10. We have live music Friday and Saturday nights. All through the summer, we got a brand new stage. Big changes happening there with new ownership. So it's been a great opportunity. Thank you.
Thanks so much, Larry. Crow Peak's been such a long sponsor, we could have one of our engineers calculate the volume of beer over the decades, or over the decade. It's quite a bit. Thanks for that. Tonight we've got a wonderful update, the update on America's Underground Lab. We're going to start with Mike Headley, the South Dakota Science and Technology Authority Executive Director that you all know, and the SURF Laboratory Director. He's going to be giving us an overview of SURF tonight, and we've got three wonderful panelists up here. David Johnson is our SURF Wastewater Treatment Plant Superintendent. Bonita Goode is the SURF Environmental Manager, and Colton Clark is the SURF Hoist and Maintenance Superintendent. We're going to hear from all three of them. Then we're going to take your questions. I'm going to be quiet and toss it over to Mike Headley. Thank you so much, Mike.
Oh, we are. Okay. All right, good evening. Thank you all for coming out. Appreciate you taking the time. And can you hear me, Mary? Okay, good. As Mike talked about, we're going to split the talk up amongst the four of us, and we were kind of talking about handling questions. We'll do the majority of the questions at the end, but after each segment, if somebody's I got to ask this right now, we'll go ahead and maybe take one question after each one of the segments. So with that, let's go ahead and jump in. And so I'm going to start out with an update and a little bit of an overview for people who are new about the STSTA and SURF. And then my colleagues will come up here and chat with you about other topics. We recently did a change out of one of the big hoist ropes at the Raw Shaft, and Colton Clark will come up and talk about that. And then our wastewater treatment plant, we've incorporated some major upgrades there. And we work very hard to be respectful of the environment. We have a number of permits, as you can imagine, that we have to live within. And so Bonita Goode will talk about our environmental stewardship, and Dave Johnson, who is the superintendent at the water treatment plant, will chat about all the upgrades. All right, so some background on the South Dakota Science and Tech Authority and SURF. And so our mission, hopefully you can read that, is it's really about doing two things. Number one, attracting and hosting the world's best underground science. We have a lot of competitors around the world, and we want to be at the top of the list of the groups that are interested in putting compelling science underground. And so that's a big part of our mission and also our vision. We want to be the preferred location for this kind of work. And then inspiring learning across generations. So things like this with public outreach. We also have a very strong K-12 STEM education program as well. And so great science and great education is what we're about. And so we currently have 225 staff members. That seems to continue to grow from year after year. We were at about 209 last year, and we're actually adding 8 more for the work that we're doing for the LBNF Dune project that I'll talk about later. And so in total, if you add up our staff and then also our colleagues with Fermilab, who are managing the LBNF Dune project, and their contractors and our scientists, it's about 400 people, kind of on average, that are working up at SURF throughout an average week. And so we're charged with we're in charge with operating and maintaining SURF and supporting the world-leading science. And so in addition to that, and providing support for everyone who's up at the lab, we also provide some direct support, actually under contract, to the LBNF Dune project, like operating the Ross shaft and the Ross hoist, which Colton will talk about. We're doing that pretty much exclusively for the project right now, and they pay us to do that. And so we're a direct actor in helping their construction work happen. I mentioned K-12 and public outreach, and our day-to-day activities are funded through a direct relationship that we have with the U.S. Department of Energy. It's called a cooperative agreement. It's kind of like a grant that has a level of oversight from DOE. And we've had that in place for a number of years now. We're actually in the 7th year of it, and that will be coming up for renewal in September of '29. So just briefly, we're a multidisciplinary lab. We're working with groups who are doing geology, biology, physics, and the physics experiments tend to be the larger projects and the ones that are, frankly, more money intensive to be able to build and operate. And then also we work to foster commercial partnerships. We just completed a multi-year partnership with Caterpillar, and where they were operating a Wi-Fi based personnel and equipment tracking system that we use throughout the lab now primarily for safety purposes, so we can track where all the humans are at in case we have an emergency. So a broad science program, and the majority, I mentioned the physics experiments, the majority of those happen down on what we call the 4,850-foot level, or the 4,850 level. So over on your left, we have the Davis campus. This has been in operation now since, around 2010, I believe. A little bit after 2012. And so that's where we've been doing the main experiments that you've been hearing about, like the LZ dark matter experiment. World's leading dark matter experiment operates there now. The Myrana demonstrator, which is a smaller experiment that's been trying to study neutrinos. They're wrapping up their work. They're actually decommissioning right now and will be complete their work here at SURF by the end of September. And we're actively working to get new science activities to go into that space where they're currently located. And as we transition over from the Yates shaft and the Davis campus over to the Ross shaft, we have the LBNF Dune area that was excavated. That was completed a couple of years ago, and we're going to spend quite a bit of time talking about LBNF Dune and the work we're doing for them tonight. And then also, 3 years ago, we got some money from the state to start the first phase of a 2-phase expansion for even more space, and that's what you see here in the yellow. That was about a 4,000-foot-long tunnel that we constructed to allow us to build the caverns that you see here in green in the future, allow us the ability to do that. So that's the layout down on the 4850. We're going to kind of focus in on LBNF Dune. So we've been talking about this project for a long time. It involves kind of what you see in this graphic of where Fermilab, with their particle accelerator, produces one of the most intense beam of neutrinos in the world. And so if you're trying to study neutrinos, it's really great if you can generate your own and doing it in a controlled way so you can study how they change as they travel. And so what we're doing with this project with Fermilab is they'll be directing a beam of neutrinos through the Earth. There's not a tunnel between here and Chicago. They're very weakly interacting, so they go right through the rock and the soil. And as I'll show you in pictures over the next few minutes, we're Fermilab with support from a lot of different groups is building, we'll be building large detectors down on the 4850 level to do the detection of those neutrinos and try and understand how they change over time as they fly through space. And so there's some pretty specific science goals associated with the project. I think really to kind of sum it up, what we're trying to do with LBNF Dune is figure out really what happened at some of the earliest stages of the universe and why, and the laws of physics really don't explain this very well, why we live in a world that's dominated by matter. So all the matter that you see around you and the people you see around you, physics really doesn't explain that very well, how that came to be. And so that's really one of the main goals of the experiment. So kind of zeroing in, we have the, I'll follow Matt's lead and actually use the pointer like they tell me to. I am trainable, but it takes a while. So here we have the caverns for LBNF Dune. The actual detectors will go in the north and south caverns that you see here. You can see one of the detectors right here. And we'll show you some pictures of these momentarily. And then that cavern going down the middle is a support equipment cavern that has a lot of equipment related to handling and keeping cool liquid nitrogen and also liquid argon, which is the argon is the main detection medium inside the detectors for detecting neutrinos and being able to understand them better. So kind of zeroing in and going into the south cavern, this is the one that's really the furthest along. And so this cavern, as you can see the end of it, it's about 475 feet long, 92 feet tall, and 65 feet wide, and is large enough to be able to hold eventually two dune detectors in this cavern and also in the north cavern. So the cavern is basically almost ready to go for us to be able to start moving the dune experiment in and all the pieces and parts that are needed to build it. The white covering that you see on the wall, it's basically like a rhino lining material that you would see if you got the pickup bed on your truck, sprayed with rhino lining or what have you. And so that's one of the last layers that will go on the walls and the ceiling to make sure that all of the rock will stay where it needs to be for 50 plus years into the future. So the caverns, the detector caverns, the south cavern is pretty well ready to go, and this is where the first detector of two will be constructed. I really love this picture. If you can, hopefully you can see the people kind of here in the foreground or in the, for scale. It really kind of gives you an idea of the enormity of these. And one of the cool things about being able to, or having to support periodic tours to go down and take a look at this is you go into the caverns and you're reminded at just how massive these are. These are some of the biggest caverns that have ever been excavated at this depth. And so really kind of a mind-blowing experience to go down and see those as part of your day-to-day job. So the central utility cavern down the middle, there's quite a bit more support equipment that's going in this cavern. I like to kind of equate it with, if you think of building a house, and so excavating to do this kind of work, it's kind of like framing a house and getting it ready to put all the utilities in it. And for the last couple of years, the project has been in the process of putting all that infrastructure into the cavern. So all the wiring and the HVAC and communication systems and systems for fire suppression and that type of thing. That's really what's been happening in earnest for the last couple of years in preparation for the installation of the Dune experiment. So there's a lot of logistics involved, and you're going to hear some of this also from Colton, but really everything that, as you can imagine, that is going underground to go into the caverns and be a part of the installation of Dune has to go down our shafts. And we have two main shafts, the Ross and the Yates, and the cage compartment where we carry people and equipment and supplies underground is about 5 feet wide by 12 feet long. So it's not very big. And during the excavation, we moved some of the largest mining equipment that exists in the world, down to the 4850 level to do all that work. And basically for the most part, you do it by taking things apart in small enough pieces that you can get them in the envelope of the shaft and get them underground, whether that's in the cage or slung below it. And so as we're preparing for the installation of dune, as I'm going to talk about in a moment, we've got a lot of I-beam steel, very big and awkward and heavy I-beam steel that has to go underground that really is the framework that builds the detectors. And so to do that, you can see over here on the left-hand side, this conveyance here, and then part of it right here. There's a conveyance at 60 feet in height that is made specifically for us to be able to put very long steel beams into it, and I'll show you how we do that here in a moment. And to get them underground so that we can take them out and get them to the caverns for the contractor who is going to do the steel erection to take all that steel and build the outer framework for the detectors. So that's what's called the raw skip conveyance, because it's located in the skip compartment, and a skip is basically a conveyance that we use during the excavation to bring rock up to the surface to put it up over in the open cut. So that's been taken out. We have a really big tall cage in there now to be able to move steel. In our personnel compartment called the cage compartment, we're putting in a new double-decker cage, and that cage will be going in over the next few weeks, and in preparation for that, we had to change out the hoist rope to put a stronger one in, and that's what Colton's going to talk about in a few minutes. And so this cage, the new cage is being built by a company called FK Lakeshore in Indiana, and as part of the building of the cage, there, as you can imagine, there's a mechanism on the cage that if the hoist rope were to go slack, it would grab onto the shaft and hold the conveyance in that location so it doesn't fall down the shaft. Well, that mechanism has to get qualified as part of, tested out to make sure that it works right. And that's what you're seeing in this picture here is basically we take the very top of the cage, it gets loaded up with enough weight to represent the weight of the cage, and then it gets dropped, and when it gets up to full speed, it grabs into the wood guides and shreds them, basically, is what you're seeing in that picture. So that's part of the process of getting the cage tested out and that we know that it's going to work and be safe when it gets here. All right, so let's talk about dune for a minute. So the dune project has actually built 2 prototype detectors located over at CERN, over in Geneva, and that's what you see here on the left-hand side. This is one of those. They're about 25 feet in each dimension, and you can see the people there for scale. So while those look very big, one of those is 1/20th the size of one of the detectors that will go underground here at SURF. So just to kind of give you an idea of the scale of those in comparison to something that you can actually see that's real today. So for each of these detectors, the outer portion that is going to get built first and hold all the liquid argon is called a cryostat. And I've been mentioning all this large I-beam steel. You can see the people over on the side and for scale, and this is enough steel to build one of the 2 cryostats. This is sitting on the dock in Spain after it was fabricated before it got put on a boat to bring it over to Houston before it was trucked up to Rapid City. So it kind of gives you an idea of the scale of all that stuff has to go underground through the cage to be able to build dune. So that steel is in the local area. If you drive past the School of Mines and then past Dakota Warehouse just down the street, you'll see there is quite a pile, multiple piles of I-beam steel that are sitting there. That's what's going to come up here via truck starting in May and get taken down to build the dune detector. So we've been practicing, or at least planning to practice, and we finally did some test movements, or a test movement of one of the larger beams. You can see this here. This beam is a little over 43 foot long and weighs almost 16,000 pounds, so quite heavy. And you can see for scale, the gentlemen who are standing next to it, who are part of the crew that's going to rig it up and get it into that skip conveyance. So we're going to watch a couple of videos. And so you're going to see us rig this up, and Jeff Barthel, who is just right here, Jeff leads our rigging activities, and he does a lot of work with our team in planning out, really the lead for planning all this work. So months of planning, and that took like 18 minutes for our folks, and it really kind of speaks to putting a lot of time and effort into the planning so the job goes well, right? So we had to take it out when we were done, and this kind of simulates what's going to happen down on the 4850 level when we take it out of the shaft and transport it over to the LB&F caverns for construction. So the project won an award recently, the Project of the Year by the Underground Construction Association. And I had to laugh a little bit if you read that full first paragraph at the end where it said, little or no issues. And I thought, this had to have been written by someone who's never been here. So there were issues, but the project was amazing and got done, got built. Just briefly, before I turn it over to Colton, I want to mention we still have an amazing K-12 education and outreach program. We've got a number of areas that you can see here that make up that program. And just to show you some of the statistics, if you look over on the far right-hand side, you'll see that our small staff of about a half a dozen worked with over 22,000 students in K-12 education here in the state. And they also provided just a ton of professional development time for over 400 teachers here in the state. So we're very proud of this and glad that we're contributing to advancing science education here in the state. Neutrino Day is coming up. Wanted to give a quick plug for this, so we've got a quick video to talk about Neutrino Day. You want to turn up the sound? We're missing all the jaunty music. So Neutrino Day is coming up. Oh, there we go. Okay, July 11th. Please come up and see us if you're interested in volunteering. Ann Metley, our head of communications, has her hand up right there and would be happy to chat with you about coming and joining us for a half a day or a day. It's a lot of fun behind the scenes, not only to participate, but to be behind the scenes helping it happen. Our Institute for Underground Science at SURF has made great progress. In interest of time, I'm going to kind of keep this short, but basically we had a huge growth in participation over 125% over where we were previously, as you can see on the bar chart. And we've got a lot of things coming up in efforts to grow the programming for the Institute. We have a new lecture series named after Dr. John Bacall, who worked with Ray Davis, developed a lot of the theory behind the experiment that was first here starting back in the mid-60s. And we actually had John's wife. John had passed away a few years ago, but his wife, Netta Bacall, is a physics professor at Princeton and is a complete rock star in the physics community. And she came out a few weeks ago, back in March on the 10th, and gave a talk down at the Journey Museum. And we were really happy to do this and as a cool way to honor John's contributions to some of the earliest work that led to the first Nobel Prize for this site. Last slide for me, economic impact. People like to know what's the return on investment for this place, and I can tell you that for every dollar the state has invested over the years to make SURF a success, there have been $18.50 in federal and private sources from outside that have come in. So I wish my 401k was doing that well, but really amazing numbers. So a $2 billion impact in the state in this decade alone. All right, with that, I'm actually going to hold on questions because I talked a little too long. I'm going to have Colton Clark come up and share with you the hoist rope change.
I'm Colton Clark. I'm the Hoist and Maintenance Superintendent here at Sanford Underground Research Facility. I'm going to be talking to you, giving you a little insight on what it takes to change a hoist rope on one of our big hoists up here at the Ross. And so I had the opportunity to be involved with a rope change here this weekend, and our amazing multimedia design team actually made a video. Stephen really didn't mention to me that he'd be making this video. He did a little interview, and it turned out really great. And so it gives a quick overview on what I'm going to show in my presentation. You'll see a lot of things that later on in the presentation I'll explain. And so we'll get that started.
The rope we'll be putting on is about 6,100 feet. So the entire rope through the shaft weighs about 27,000 pounds. One of the main challenges is getting the rope, from the connection point here on top of the cage around this sheave and out to the reel. And then when we get the new rope, getting the new rope back around this sheave, up over our sheave up here, and then back down to the hoist room with the trailing rope. And then once we get it into the hoist room, it has to go around the drum, through a slot in the drum, and be secured to the drum. Those are the hardest parts. The last time we did this, it was this crew that did it, and some of the same crew from Canada is back, including the hoist mechanics. And so these guys have done this. They know what they're doing. It's gone smoothly so far, and I feel like it's going to continue to go that way, and it should be a nice, smooth project.
So, yeah, as it showed in the video, this is a picture here of the Ross hoist room. The drum we actually changed was the overline drum. Right here you can see a picture of the orientation of the drums. So these are 25-foot bicylindrical conical drum hoists. The rope that was on was 1 5/8". It weighed about 4.5 pounds per foot. The minimum breaking strength on that rope was 225,000 pounds. The rope, so when they send us these ropes, they actually take a piece of this rope and they pull it till destruction. And so this rope actually broke at about 253,000 pounds. And given our the loads on this rope, it provides a safety factor of about a 4.5. The new rope, and so as Mike spoke, we needed a stronger rope because right now, we put about 29 people on the cage, 36 in emergencies. We want to put 50 people on, 25 per deck, so we needed a stronger rope on the hoist to actually support this conveyance. There are going to be a lot of people going up and down the shaft, in and out as we begin to support the dune project, and so we need to be able to get more people underground quicker so we have more time to move materials and all of their tools underground. The new rope is a Bryden rope, same size, a little bit heavier, and so people ask, why is this rope stronger? It has to do with the metallurgy. This rope has a higher tensile strength, and so it has a minimum breaking strength of about 285,000 pounds, and this rope actually broke at 306,414 pounds. And this will raise our safety factor up to 5.7. And so when you talk tensile strength, it means the rope doesn't flex as well. But given our system, the size of our sheave wheels, the fact that the rope never touches itself. So I don't know if anyone's been in the hoist room, but when it goes onto the drum, it sits in its own groove. And so on a typical winder hoist, the rope actually winds onto itself on a smaller drum, and so it has to bend more. On our drums, it doesn't do that, and it never touches itself. And so raising the tensile strength slightly will not affect the life of the rope as we move forward. So here's some, like I spoke to in the video, on the left side of the screen here, this is the sheave they had to bolt down to the floor. And so in the second picture here, they have to, and actually this are backwards, but they have to take the connection off the top of the cage. Well, this rope has a ton of tension in it, and it wants to spin when you take the connection off. And so they tie this big wheel here to it, and then they tie it off with ropes, and then take the tension out of the rope. And so if you just pull that pin, this wheel spins around and it gets pretty hairy. And so they did that, and then they attached this wheel here, this sheave, to the floor. Then they pull the rope around this sheave and then out to this winder. And I think the video played there. So and then you can see the rope coming out. And I'll kind of zoom in, and this winder sits outside the hoist room, and it's wound onto this wheel out here. And then we'll, in the next few slides, we'll remove that and put on the new rope. So here's, in the picture on the left, this is the crane we use, and so here we have the old rope. Here is the new rope being delivered, and so we'll take this rope off and place this rope right here onto that shiv, and we'll start reversing the process, pulling the new rope back through that blue shiv, up over our shiv in the head frame, and then back down to the hoist drum. In the picture on the right here, you can see guys that are unsecuring it from the drum. You've seen in the video. It has to be secured to the drum. It goes through a slot in the drum, so it comes around the drum just inside it here through a slot, and there's 2 clamps that hold that rope to the drum. And so for our rope connections, we use a couple, and then I have, so here is a chunk. I'll pass this around. Here's a chunk of our 1 5/8" rope. This is actually fiber core. The ropes we use now are actually synthetic core. It's a polyester. We use 2 main types of connections, and then a 3rd connection to actually pull the rope up over the shiv wheels. So the type of connection we use on the cage right now is called a spelter socket. And it uses, you broom the rope out and pull it into there, and then secure it. And then the other connections we use on site are a thimble. And this, you wrap the rope around this way, and then clamp the rope using rope clamps back up this way. And so we use those 2 types of connections on all of our ropes on site, our hoist ropes on site. And then the 3rd is called a Kellum grip. And so this is, it's pretty much a Chinese finger trap. And so what that does is it clamps to the rope, and the harder you pull, the tighter it gets. And so this is how they connect the trailing rope from the hoist room up over our shivs, and then back down to that winding drum. And then this is how they get it to and from the hoist room. So it uses a 3/8 inch, much smaller rope to get it to and from the hoist room. So when they attach the new the new socket, they have to do what's called brooming the rope. And so here you can see they spread that rope that I'm passing around out, and it's probably about this big. And they got to take each one of those tiny wires, and you can't even see all of them in there, and spread them out. And then they clean it up with brake clean or carb cleaner to get all the oil off, because the ropes are entrained with oil when they're wound at the factory. So they get all the oil off, and then we hang our socket here and pull all those wires down in there, and they stay spread out for the most part when they get in there. And then they pack some clay around it here, and then they pour an epoxy grout in there, and it's a 20,000 psi epoxy grout that holds it in there. And behind me here I have, so here's one that's been pressed out, and you can see the epoxy didn't all the way make it down to the wires, but the nice part about this one is you can see the wires actually in the epoxy. And so this is what it does, and then this is how it's connected, and then they connect this back to the hoist. I'd pass this around, but it's dirty and kind of, it's got some wire or some metal fragments on it, so I'll just leave it on the ground there. And then once that process is complete, we got the wire or the rope back onto the drum. We bring in our hoist programmer, CMAG Techberg, and we have to, so there's a couple of things that happen on the shiv deck. There's things called load cells, and they do a couple of things. The load cells actually they tell us how much weight is on the conveyance. So when the conveyance is empty, it's at 0, and then you really can't tell from the picture, but you can see the weights on the conveyances. But then as we load it up, the hoist operator can tell how much weight is on the conveyance. The load cell also provides what we call a rope tension monitoring system. So as the conveyance is moving in the shaft, if that weight changes plus or minus 4,000 pounds, it means something's wrong in the shaft. The cage is either hung up as it's coming up and the rope is starting to pull tight, or if it drops below that, it means for some reason it's hung up and the hoist is paying out going down. The hoist is paying out and it gets lighter, and this stops the system. So when we put a new rope on, we have to run it through the shaft and recalibrate the rope tension monitoring system. So it's a safety system that will e-stop or emergency stop the hoist if anything changes. And so we can, it's a safety mechanism that keeps everyone in the shaft safe. And as Mike showed in the previous picture, we have the dogs. So this system should come into place before the dogging event, before a dogging event happens. The hoist should catch anything before a dogging event happens. And so if a dogging event happens, we're in bad shape. If this happens, it's not so bad. I mean, we've set it off before just in testing, and so it does work really well. And then we run the hoist. I don't know if you can hear if there's volume on that or not, but it doesn't matter. So, and then we run the hoist through its paces. Like before we put anything on it, we test all of the safety systems, the switches. Everything has to be tested before we put any personnel on it. So that takes, you know, an hour and a half to 2 hours with the hoist operator and the technician from CMAG TechBird running the hoist through its paces, and then we're allowed to put people back on the hoist. And that's all I got. Thank you.
Hello, can you hear me all right? Sounds good. My name's David Johnson. I'm the superintendent at the wastewater treatment plant. I've been at Sanford Lab for about 13 years, been the superintendent for about 3 years now. And I'm just gonna go over the process, what we treat, where that water comes from, and then the new MBBR that just came online in the past year. So the water we treat comes from 2 different sources. Of course, there's the underground water, and then we also treat the tailings pond that's south of town 3 miles. That's the old Homestake mining tailings impoundment. So underground, our deep well, it's hanging in 6 shaft. It's about 6,200 feet down. It pumps straight up the column. And it's over 1 mile long. It's got 5 different stages. From the deep well will pump up to the 5,000, the 3650, 2450, 1250, and then up to the reservoir on the surface. It needs to reset, you know, each time it goes into that pump room. Those are high horsepower, over 600 horsepower electric motors. The pressure on that column is about 600 PSI. You know, so it would take a big pump, and then that PSI would be over 3,000 had it just gone straight up that column. So the other water, like I said, from that Grizzly Gulch, it gets pumped across the surface, about 3 miles of pipeline, and the 2 different waters will blend into our reservoir up on the surface. Here's a picture of the reservoir. It holds about 2 million gallons of water. And then in the background there, you can see the water treatment plant. So we have 125 feet of elevation there that allows us to just flow through that plant, gravity fed, not using any pumps. And that's an overview of the water treatment plant. The white cylinders there are the old RBCs. And then that box that's circled there, that's the construction of the new MBBR. RBC stands for Rotating Biological Contactor. MBBR is the Moving Bed Biofilm Reactor. And I'll kind of explain these as we go. So the total process, it comes into that top reservoir. In our first filter in the water treatment process is removing the iron. These are mixed media filters. The bottom has a gravel, then there's a coarse garnet, a fine garnet, and then an anthracite coal on the top of that. Those filters will get backwashed twice a day. Get that iron water will go into a sludge tank. In that sludge tank, we'll add a coagulant and a flocculant and allow that iron to settle out. That iron then will get drained into a geotextile dewatering bag. So the iron gets captured in there, and the water drains off, and that water is going to just eventually go back to the head of the plant. Next in line is the nitrification process that reduces the ammonia to a nitrate down to a nitrite, nitrite to nitrate by bacteria, and then it's safe for the aquatic life, safe for discharge. Our final filters are a polishing filter, and they have the same media as those blue Yardney filters. However, at this time, there's only the bacteria and organic matter that's sloughed off in that MBBR. From there, it's discharged over the hill, and we provide that lovely waterfall but down there by the highway. And there it is, a 125-foot elevation. We can do that. We can gravity feed up to about 1,500 gallons per minute. Any more than that, and then we'll have to turn on a pump. So we replaced those RBCs with an MBBR. Due to mechanical failures and rising costs, obsolete parts, the MBBR was chosen to replace those RBCs. A few points that allowed us to choose that MBBR over the others. During construction, there wasn't going to be any interruption in flows. We could still run the RBCs while the MBBR was being built, and then when that MBBR was being brought online, we could kind of slowly increase the water from the RBCs until the MBBR got fully seated. And then there's a smaller footprint, reduced power needs, and it has two different cells in there. We can run water through that plant in parallel, meaning just straight across. In a series, it'll go in one cell, and then the other cell, and then out. And if there's any maintenance that needs to be done, one can be drained, one can be shut down, while the other one would stay online. We can do some maintenance if needed. And so then the new MBBR is equal to about 16 of the RBCs that were there. So here's some of the demolition pictures taken down some of the old RBCs. And this is what an RBC looks like. So this shaft here is covered with a plastic media. And on that media is where the bacteria grows to reduce that ammonia. So each of these shafts here is about 900,000 square feet of surface area. And so the MBBR is taking over 16 of those. Then we got just some excavation, some walls being poured that's 24 feet deep, 30 feet across, 15 across on each cell. This is the inside, the bottom here. You got some diffusers. We use a blower that's going to oxygenate that water and also give it the churning effect that's needed to mix that media. And then those black tubes here, there's the sieves that'll allow the water to drain out but keep the media inside that tank. So here's what the media looks like. And there's actually some samples in the top of the model in the back of the room there. But they're just small, little wafer-looking honeycomb discs, about 1 inch wide, 1/4 inch thick. And so the bacteria grows on the media to allow the bioremediation of the ammonia, where it's reduced then from a nitrite to a nitrate. So all of these little wafers combined is over 1.5 million square feet of surface area. The aerobic conditions are created with blowers, and the aeration grid at the bottom of each basin increases the dissolved oxygen, and like I said, creates that churning effect to keep that media mixing so that there's a complete coverage on all the water and media there. So here's some more pictures. The media came in big cargo containers. There's 3 of them. There's 180 super sacks of media, and that's what's behind the pickup there. They were loaded in with a crane, doing 4 bags at a time. It went much faster than anticipated. And so on this screen, that is all the media inside the basin. And so when we first got them loaded, the manufacturer said it would take about 3 or 4 days to get that all wetted in there, kind of like on that 4th picture. Well, I was getting concerned. It took about 4 weeks. However, so our water isn't like your normal city sewer system. You know, they have a lot of other stuff. And so it didn't have a lot of attachment to grow on that media to get it blended in the water. So that is now what it looks like here working today. And a little up-close picture on the right there And there it is. Our ammonia comes in about a 2.0 parts per million, and when it leaves, it's almost non-detect. It's less than a 0.05. So, all right.
Good evening, everybody. My name's Bonita Goode, and I'm the environmental manager. So Dave talked about the wastewater treatment plant process. I'm going to be talking about the wastewater chemistry going into the plant and also coming out of the plant. And then I'm going to discuss a little bit about our Clean Water Act compliance, mostly from a permit. So we have to have a permit to discharge our treated water to Gold Run Creek. So I'll just kind of give you a summary about our record on that complying with that permit. Okay, so this is some wastewater chemistry coming into the plant. So this left-hand column here is the analytes. Then we have the lab dewatering water, and we have the Grizzly Gulch water. So you can see the picture here. That is actually an underground pump room. So Dave talked about the different sump levels, the different levels. So this is a picture of a pump room. And this picture here is actually up at the Grizzly Gulch tailings impoundment. And there's a pump house there, and then that's where it starts its 3-mile trek down to the wastewater treatment plant. So you can see on the temperature there is that our lab dewatering water obviously is very warm, and we do have a permit limit for temperature of the stream when we discharge the water into the stream. So it can't be too warm, can't be too hot. So the Grizzly Gulch water actually provides a good amount of cooling, so we don't have to have like any cooling in the wastewater treatment plant. So if we ever lost the Grizzly Gulch water, we'd have to do some kind of cooling of the water before we could discharge it. Cyanide kind of is an obsolete thing now. Obviously, it was used in the homestake days for the milling process, so that we don't have cyanide anymore. It never came from the underground, so that's below detection. So if you see the less than there, that is less than what the lab can detect when we send the sample to the lab. And then also on this milligrams per liter here, that's actually a part per million. And just to give you an idea, a part per million is 1 drop of something into a 55-gallon barrel of water. So we're talking really low levels of detection here for the pollutants. So ammonia, from the lab, the dewatering of the lab is about 3 to 4, but that's when we're blasting. So now that the excavation is done, we don't really have any blasting underground, so that should come down. And then the ammonia from the Grizzly Gulch water, that actually comes from the cyanide being broken down. So it's no longer cyanide up there, it's ammonia. And so that's where this ammonia comes from there. pH is basically neutral, so we don't have a problem with pH control, so we don't do any pH control in the wastewater treatment plant. It's pretty much, we can discharge it. The total suspended solids is mostly probably from the iron, and you can see the Grizzly Gulch water, the total suspended solids, so that's basically dirt in the water, is really low, and that's because there's nothing actively being put into the tailings impoundment anymore, so it acts kind of as a settling pond, so all the sediment comes out, so that's why the suspended solids are so low. And I will talk about iron a little bit later in a different slide, but most of the iron you can see is coming from the lab dewatering water, and that's just all the legacy infrastructure that's either underwater, below the deep pool level, or just in general, just a wet environment, so there's a lot of iron. So this is the Clean Water Act monitoring. So this is what we monitor for. This is what's required by the permit that was issued to us by the state of South Dakota. So daily, we do total suspended solids, ammonia, pH, flow temperature of both the discharged water and the receiving water. Weekly, we do cyanide, arsenic, copper, lead, mercury, silver, selenium, nitrates, hardness, and total petroleum hydrocarbon. Monthly, we do biochemical oxygen demand, which is basically organics in the water, cadmium, chromium, nickel, and zinc. And semi-annually, we do a whole effluent toxicity testing. And that's where we expose, or we don't do it, we send it to a lab in Wyoming. They expose our discharge water, they put water fleas, and they put fathead minnows in it in various levels in our discharge water, and they either live or die. So it's a pass or fail. So, yeah. So I'm happy to say in 16 years since surf took over, no little organisms have died. So we've always passed that. So we also we do Whitewood Creek above and below our discharge. We do monitoring of that regularly. A monthly arsenic, cadmium, chromium, copper, lead, mercury, nickel, selenium, silver, zinc, pH, TSS, TPH, cyanide, and hardness. And then annually we do aquatic biomonitoring, which I'll talk a little more detail in some later slides. But as you can see, there's a lot of monitoring of the water that we discharge to the local creeks. So this is an example of the wastewater coming out of the wastewater treatment plant. So the first column there is just one of our weekly samples from February 2026. The second column, milligrams per liters, that's the concentration from the lab results. Third column is loading into the stream. So that's in pounds per day. We generally discharge about 2 million gallons per day into Gold Run Creek. So basically taking that times the concentration, then you get the amount that you're loading of the pollutant into the creek, okay? So as an example, Dave was talking about our success with the MBBR and getting the ammonia very low. You can see that it's below detection. Therefore, we calculate pounds per day we put into the creek. It's 0. Our permit limit is actually 25.4 pounds. So we would be allowed to discharge that many pounds of ammonia per day into the creek. And those permit limits are set to protect the creek, the aquatic organisms. So you can see that we're really protecting the aquatic organisms. So that's a good thing. And then the MBBR goes from ammonia to nitrate to nitrates. And you can see that we are very low on the nitrates, 2.26. Anything less than 10 is basically not harmful to the aquatic environment. So the rest of the things here, you can see that are very low. I mean, basically they're all non-detectable. The only thing we see is arsenic, and we're still only doing about 0.1 pounds per day into the creek, and our permit limit is 9.6 pounds per day. So we're way below the permit limit. And yeah, that's pretty much. We do see some nickel. You'll see nickel here, 0.12 pounds per day, but there is no permit limit for that. We just have to report it. So we're, some good results there. So how much water has surf treated since we took over the Homestake mine? 10 billion plus gallons of water has been treated and sent to the creeks. You can see Pactola Reservoir holds approximately 18 billion gallons of water, although right now it might only hold 10 billion gallons, right? So a lot of water, and that's about the same as what you could supply 83,000 average US households with potable water for a year. So a lot of water has been treated and sent to the creeks. So this is a very positive thing. We have 0 permit violations. So the permit that was issued to us, we've never had a violation in 16 years, with 10 billion gallons of water discharged and a lot of sampling done. So very proud of that. Kudos to the wastewater treatment plant, right? Because if we couldn't dewater the underground, the lab wouldn't be in existence. It would be underwater. So for every day we don't pump, it rises 1 foot. So right now, I think it would be, 1,000 days before it would hit the 4850 if we stop pumping. So, you know, it's really important to have this permit compliance. So I talked a little bit about the iron. So the infrastructure, you have the roof bolts, you have the overhead utilities, the rail cars, anything below the deep pool level So from about 5,500 down to 8,000, that's all flooded. And that's all these kinds of steel things are flooded out. And also, even above that, you got a very wet environment. Everything's rusty. So the deep pool has a lot of iron in it. It's red and orange color when it comes up from the underground. So you have to get the iron out. So when Dave went over the wastewater treatment plant process, the first step was those primary filters to get the iron out, and that's a very important step. So you can see we did quarterly samples, and the iron in each quarter was 0 at discharge, even though it came in as pretty high, milligrams per liters. So the next thing I'll talk about is we have done annual aquatic biomonitoring for 16 years. I shouldn't say we've done it. We hire a company out of Colorado. So they come in with a crew of about 4 people. They do a very extensive study of the local creeks and what our impact at surf is on those creeks. So they do habitat assessment, fish populations, fish tissues, macroinvertebrate populations. Those are the small aquatic animals without backbones that live on the bottom of bodies of water. Periphyton population, those are the algae, bacteria, and fungi that attach to submerged surfaces in aquatic ecosystems. So there's 4 different monitoring locations in the creeks, and they do this amount of study on every single one of those locations. So this is a picture of what the study map looks like. So here's outfall 001. So that's where the wastewater discharges into Gold Run Creek. So GRA is above our discharge. GRB is below our discharge. Here's the confluence of Gold Run Creek with Whitewood Creek. Then you have WWCA, which is above the confluence, and WWCB, which is below the confluence. So here's some pictures on the right there. They're doing some electrofishing. They're weighing some fish, and they're measuring some fish, just part of the annual study. So when we actually get the report back, it's 200 to 400 pages. There's lots of data. So I just included basically the executive summary section of what the report looks like. So Gold Run Creek, site GRB directly downstream of the wastewater treatment plant discharge consistently supports more robust macroinvertebrate and periphyton communities relative to site GRA. So you can see here, here's our discharge, that beautiful waterfall that Dave was talking about. This is above GRA, the discharge, and this is below. So visually, you can see it's a much more robust environment for aquatic organisms. No fish have ever been collected in Gold Run Creek. Over the 16 years that these studies have been done, the section of stream below the wastewater treatment plant is probably too short to support a fish population, and there's we all know, right, there's a big culvert that runs right in the confluence. Well, fish can't migrate up that to get into Gold Run Creek anyway. So Whitewood Creek, both sites, A and B on Whitewood Creek, support a robust self-sustaining population of brown trout and small numbers of brook trout, mountain suckers, and long-nosed dace, whatever those are. They sound scary. Aquatic communities are consistently healthier at the site below our outfall and on Whitewood Creek compared to sites on Gold Run Creek, which would not be expected if inflows from the wastewater treatment plant were negatively impacting the creek. No evidence for negative impacts were observed in fish, invertebrate, or periphyton population data in 2024 or the previous years. I just got the 2025 report today, so I wasn't able to use that as a quote, but anyway, we have really good monitoring results and really good results from the study. So just to switch gears really quick, so we're done with the Clean Water Act stuff, is SURF received an EPA Brownfields grant. The grant program aims to transform historic use areas into productive properties that enhance local economies. So SURF was awarded a $1 million grant in 2025 and has 5 years to use those funds. You probably saw it in the local news or some of our social media posts. So we're really excited about it. We'll be doing environmental assessments at some potentially contaminated areas and perform some asbestos remediation of some of our old buildings with that money. And if you'd like to learn more, here's another plug for Neutrino Day. We're going to have a brownfield grant booth at Neutrino Day, so please come visit us and give us your input. So that's all. Thank you.
We've got time for a few questions from our panelists.
Yeah, absolutely.
What questions do you have after that? I've got one all the way back here. I'll come back.
My questions are on the water purification system. One, I understand in the early days they literally used trout inside the water system for the same reason that the minnows are used today. If the trout made it, things were good. Am I correct in that?
That is correct.
Okay.
Instead of doing it in-house now, that's what Bonita said was the wet test, the whole effluent toxicity test, and they do that on the minnows and the small invertebrates.
So it's nothing at the water treatment plant?
Correct. We still have the fish house, and we call it the fish house.
Okay.
There's just no fish in it.
It's okay. My second question, again, what I've heard over the years, the water that comes down the waterfall, if you took a cup and put it in there for the purposes of drinking, would it have any, I don't mean negative effect, I've been told that it would literally, it is so pure that it would burn your mouth.
I would not recommend that.
But it is almost that pure, am I correct?
It's clean water, but it's far from pure, and it hasn't been disinfected.
Okay, didn't know that. And my third comment, Mr. Jim Whitlock would be very proud.
All right, he's a good man, thank you.
What other questions might we have? That was excellent. Anyone else? We've got another one back here.
Just want to clear this up. I believe that the Central City location plant is nothing with anything that you presented tonight. Is that correct?
That's
off of
right.
Highway 14A?
Yeah, that's operated by Barrick.
Okay.
Very proud of the water treatment downstream. We're able to catch trout down there, and that's a wonderful thing for everyone in the community. I'll get right back to you.
They changed the cable because it wasn't beefy enough. Is there a resale on that or just recycle value?
Actually, it was wound on that drum, and then we store it in on site to use it as a spare. So that if we were to have issues with either of the 1 5/8 ropes, we have that one as a spare, so we could put it back on if we needed to. So we have spares for all of our ropes on site.
Can you talk about the new experiment coming up, the Dunes experiment?
The Dune experiment?
Yeah.
Yeah. Is there something specific I didn't mention earlier?
Just in general, what you hope to accomplish with the experiment?
Yeah, the Dune experiment will run for at least 20 years to meet its science goals. And so, it won't be continuous. There's times when the beam won't be on, but for the majority of the time during the year, the beam will be running. And the neutrinos will basically recoil with the atoms of the argon that's in it's about, I think, like 3 million gallons of liquid argon in each one of those detectors. And so there are elements that are within the argon volume that will read out the electrons that are produced from that interaction of the neutrinos with the atoms of argon, and then processed. And what they're trying to figure out is neutrinos are kind of an interesting animal. They're the only particle we know of that changes from, there's 3 different types of them, and they change from one type to another as they fly through everything. And so we're expecting the neutrinos that are generated at Fermilab to go through one transformation between here and there, and trying to understand how the negatively charged neutrinos and the positively charged neutrinos do that thing the same or differently. In really simple terms, it will help us understand. through using neutrinos what happened at some of the earliest stages of the universe. There has to be a scientist in the room that can give probably a better answer than that. But I mean, that's really what we're trying to do. Yeah.
We've got another question right here in the back of the room.
Good evening. My question is for Colton. I believe in your talk you talked about a 4,000 weight limit or something that the machine would, the shaft, it would stop the rope. You know, if there was a, with all due respect, I don't weigh 4,000 pounds. Why 4,000 pounds? Why not 200?
Well, so the weight of the rope is a big part of it. And so if you ever, and I know you're an employee up there, if you ever go over to the shaft, you can watch that rope kind of wiggle. So the weight fluctuates based on the load cells, because the load cells are up in the head frame, and so that weight fluctuates slightly, and so they know once it's reached that 4,000 mark, it's not a fluctuation. There's an actual issue happening, and so that's why they set the threshold right there.
So it's okay to jump up and down on the cage when you're in there?
Absolutely, have a party in there.
Well, any other questions we have here this evening? What other questions might you have for our great panelists and guests? We got one up here.
Oh, I don't need a mic. Oh, okay, for online. Okay. The two different levels, or the pH amounts from the pond and what's coming out of the mine. Can you explain what the difference is in that? Why the one from the pond is so much higher? The pH was like 8.
I don't. It might be the cyanide hydrolysis that's causing the pH to come up a little bit, as opposed to just being just a very neutral pH, water pH. Probably what's happening within the pond.
We got time for maybe one more question. Anyone else out there? I've got one more.
Saying about the 1st of May type of thing. When will the I misspoke. When will the argon gas be taken up? Next year, 2 years?
No, it'll take, Jim, what, 1 year to build the... Sorry,
1 year to build the cryostat.
Yeah. Yeah. Yeah, oh yeah, definitely. The, via truck. The argon? The argon will be brought up in tanker trucks. Yeah. And it'll take about a year to fill each one. And I think I can say this without getting in trouble. The project is trying to get all this work done and get the beam. There's a lot, and we didn't even talk about any of this, but there's a ton of work at Fermilab to modify the neutrino beam, because currently it points at northern Minnesota. We have detectors that they've been operating up there for a while, so they have to modify it to point it at South Dakota and upgrade it to make it more powerful, and there's a lot of work there, to say the least. The work here was prioritized first because there's science that can be done, certainly not the full suite, but there's science that can be done even if we don't have the beam, and so that's why the work here in South Dakota started first. So, Jim, this is Jim Kirby. He is the project director with LBNF. He's my counterpart at Fermi. He's out here this week, and Jim, anything you want to add about the project? Go ahead.
Mine, sure.
Yeah, go ahead.
So we'll do just about anything for a beer, so thank you to Crow Peak for that. Actually, is he still here? Sir, could you pour me one more? No, I'm serious. Right now, I need it for an experiment. I want to show you something. It's actually not for drinking. I've had enough.
We don't hand the mic to Jim too often, as you can probably figure out.
If you don't mind, just... I will use it. Okay, look, a couple of timeline things. So, hi, my name is Jim Kirby. I'm the project director for LBNF Dune, and it is an extreme pleasure to work with Mike and the team at SURF on getting this done out here. Okay, it's a really big deal, and a little bit of a launch ahead. Just a few weeks from now, there will be a signing ceremony here for some of the first steel going underground. There will be people from the Department of Energy and other places, and probably, I don't know, 8 or 9 countries that come here, because this will be the center of the neutrino universe for decades to come. It's kind of a big deal. And Daryl Gill, the Undersecretary for the Department of Energy. And so, you know, it's a big deal. It's a big deal. It's a really big deal. All right, so timeline. So yeah, we're gonna start construction this summer of the cryostat underground. It's 7 million pounds of steel. One way to look at it is each piece of steel It's one description, if you scale it, it's like building a 787 by passing every piece of steel through your cat door in your house. Okay, so that's the logistics issue. Now, Mike and team showed you the shaft, we put everything down, but that's what we got to do, okay? And then we'll put in 14 kilotons of argon. And then here's what we do. Okay, so this is why I asked for the beer. I will visit shortly. I will do just about anything for a beer, except mess with my family. I've been married 33 years. That doesn't happen. But, okay, if there was a bubble here, you know, usually there's a, pour yourself a beer, there's some bubbles going up, okay? And so imagine, science experiments are best when they can be described with beer. So imagine that you're tracing where one of those bubbles starts from in your beer. And usually you can trace it down and it runs into the side of the glass somewhere or something, okay? And so there's a nucleation site where that bubble started from in your beer. Our liquid argon detector is essentially the same thing. We have a stream of neutrinos coming from Fermilab, and it will hit the liquid argon, and some of them, very few of them, will react with the liquid argon, and we will create a trail in the liquid argon that we can measure because it's in an electric field. And by measuring where all those bubbles started, it tells us something about what that start point is. All right, and that helps us understand each one of those neutrinos that comes through. Mike's exactly right. We have 3 different types of neutrinos. Neutrinos are as common in the universe as photons, as light, X-rays. We know almost nothing about neutrinos. We know lots about photons, but we know almost nothing about neutrinos. And so the point of this experiment here is to help us understand all those neutrinos. There are millions of neutrinos going through your thumb in the time I just shook my hand like that. They are the most weakly interacting particle in the universe. We don't understand them, and we don't honestly know exactly what we're going to learn by doing it, but it's a great unknown. And so it's a great search for us to go on to find out. There's a lot of work that's going to be going on here. The cavern's basically done. The infrastructure's done. We're going to get started on the cryostat. We'll start experiments here using cosmic neutrinos in about 2030. Right, it's going to take us that long to get going and fill it up and everything else, check everything out. At Fermilab, we are starting on construction of a sort of massive amount of civil construction. I have to point a beam of neutrinos from Fermilab to here. To do that, somewhat strangely, the Earth's round, and I have to point things down 6 degrees, so I actually build a mound of dirt 6 stories high, curve it around, and then point it underground to do it right. That's the most cost-effective way to do it. And we're just getting started on that now, and the beam completion and stuff will be a couple of years afterwards, okay? So I just want to, that's the short version. I'll stick around a little bit if you've got more questions. I'm happy to try and answer them. I'm an engineer, I just build stuff, but I've been doing this a while. It's really important that we're here, and we're very glad to be here, and we're very glad to partner with SURF on this and going forward. And it's been a pleasure to work so far, and we can't wait to get started, so thanks very much.
Thanks. That's great. That's great. Thanks.
Yeah, thank you so much. It's been a wonderful evening. We maybe have time for one more question?
So not at the moment, but you know, it's kind of funny. We're having some tours coming up here somewhat shortly, and it's reminded we really need to restart this. I rediscovered a talk I gave about 15 years ago at Fermilab with Deborah Harris. She's a professor at York University in Canada now. But about 15 years ago, she and I were given talks about accelerators and neutrinos at Fermilab and taking people on tours underground and stuff. And reminded by a couple things out here, I was reminded we really need to restart those. So Fermilab's an open campus between the hours of 8 and 5. You need a real ID. But if you come visit, there are some places you can visit, and we'd be happy to see you. So.
Fermilab will be here on Neutrino Day as well on July 11th, so it's going to be wonderful. The date you mentioned.
You're going to plug the May 7th?
Yes, May 7th.
Yeah, go ahead.
So on May 7th from 2 to 4 p.m., we're going to have one of the large beams for Dune that you saw the video of, and we want everybody here to come out and sign that beam. We especially want young people to come sign that beam. Those kids in grade school today, they can be the scientists, the engineers, the technicians working at SURF tomorrow. Dune's going to go for 20 years, and it's going to start in 2030. That means in 2050, those kids, they can still be here working at SURF. That's awesome. I want some of those kids to be able to sign that beam and say, my name's underground. That's what I'm hoping for. So we want the whole community of Lead to come out May 7th between 2 and 4. And then we have, we're going to focus our next deep talks on Dune, May 21st. It is, I think it's being billed as Young Dune. It's one of the early career physicists who's working in Dune, who's going to be here for a Dune collaboration meeting, is going to come give a talk on the science of Dune. So there'll be some scientists here who can really take a deep dive and nerd out with us all. It's going to be a lot of fun. So we hope you come back on May 21st. Of course, we'll have more beer from Crow Peak and our sponsors. Those things coming up. Anything else from the panel this evening we need to add I might be missing? Let's give one more round of applause for this great thing. Thank you all for coming out. If you have more questions, feel free to stick around.